Welcome to another episode. Today I'm joined by Ankit and Stephane, the co-founders of OneBalance and the minds behind one of the highest TV publications in crypto, Frontier Research. So I've literally read like every article and absolutely love how you guys think about the ecosystem. So I'm like super excited for this conversation.
Yeah, thank you so much for having us. And I saw that you posted the intent value chain post, and I thought that was really well and then thought out. So I think you're just up there with us, and I'm just sad that you didn't post it on Frontier Research.
Again, like super inspired by everything that you guys do, and I feel like. I feel like Ankit also said this once in some of the podcasts. Like you need to build on top of what other people work on. So you guys worked on the MEV supply chain, and then I felt like this was great inspiration for us to write this article.
Yeah, thank you.
Okay,
Standing on the giant of shoulders is what Isaac Newton said.
Yeah. So like just to set context, like we're having this conversation at a time where there's growing interest around like resource locks, and everyone is talking about Interop. Like there are too many Telegram groups, a lot of discussions going on, and there's a world where like the implementation of resource locks can solve some of the UX like fragmentation problems, right? So I want to use this conversation to like learn more about resource locks and also get a sense of like what a world with resource locks looks like eventually, right? So like maybe let's start from the top. Let's start from the basics. Like, what are resource locks?
Yeah, so maybe just jumping in, I think you mentioned the sort of topics on resource locks. So recently, the EF sort of tapped their shoulder and said, "Hey, we have these grand plans. We have this Interop working group, and we're looking for help, sort of making sure that this is fostered in the right direction." And they asked us to help sort of come co-chair the resource locks and intent working group within their thing. So I think there's more and more people that are paying attention now to it, and it's great to be here and chat about it. I'm happy to toss the ball over to Ankit for him to sort of cover a bit what resource locks are.
Yeah. Thank you for providing that context. I think we wrote about the resource lock, what resource locks are, and how we define that almost a year ago. And it's nice to see adoption and people talking about it, and not just us two talking about it and posting on Twitter and other people using the same terminology. And so it feels nice when that happens. So let's just try to understand what we mean by resource locks. Let's take a step back and see how cross-chain happens today. And so if you want to do any cross-chain transaction, if you want to basically suppose send $10 from Base to Arbitrum, you would first send a $10 transaction to the source chain bridge or an intent network. And so that is your transaction number one. And then there is some entity on the target chain. Maybe it's like a solver or it's a bridge who's just waiting for finality on your transaction number one, which is source chain transaction. And then only once they have some confidence that they won't be equivocated or they will eventually get the money, they front you the money on the target chain. So it's a very serial operation. Step one, source chain. Step two, waiting for some time. And then step three, giving you the money. And this is also how all the centralized exchanges work. So all the centralized exchanges, they give you some address, you deposit funds in them, you wait for a certain number of blocks, and only then you get the funds in their L2. And so what resource locks are at the end of the day is just, instead of, it decouples these like three step-by-step serial operations into some things that can happen in parallel. So with resource locks, the only thing that the user needs to do is just sign a transaction. And then based on that signature, the solver on the other side can just look at that signed transaction and say, okay, like I'm confident that I'll eventually get the money. I don't need to wait for 10 minutes, 5 minutes, whatever is the inclusion speed of the source chain. And I just front the money right now. And so what it helps you do is it decouples the dependency of a cross-chain flow from the source chain inclusion speed. And that's what resource locks are at the end of the day. Instead of signing, waiting for inclusion, and then getting the money paid, the only thing that you need to do is sign, which takes milliseconds, and then as soon as the solver sees that, they can front you the money.
Makes sense. So like I think one way you have described it in many conversations is that these are like faster or resource lock intent bridges, right? Because you have better guarantees for the solver, so they can just go out, do their job without waiting for source chain finality. But if you zoom out, what's a good way to actually think about resource locks as a concept in general? Like outside of bridging, in general in crypto, do you guys have a mental model to think about it?
I think Stephane would have more opinions on it, but one way I think about it is you are basically locking your funds a priori into some sort of a mechanism, and then because you have logged your funds, you can just instantaneously use them anywhere on all the supported chains. That's one There are HTLCs which were in Bitcoin, and after we wrote the resource lock piece, we found more and more examples of people who have implemented something like resource locks in their own silos, but it never escaped. It never escaped their own organization, basically.
Yeah, the abstract concept of a resource lock is really a credible commitment, and and in particular, it's sort of an attempt at allowing accounts to make credible commitments to solvers about the assets that they have available for spending, without requiring L1 consensus and L1 validators to attest to those commitments. And so it's really just recognizing that different types of commitments require different levels of security, and a commitment to a solver as part of an intent bridge doesn't require the same level of security as securing the native ledger for Ethereum. And so there's a lot of optimizations that can be found by putting a different security model on those credible commitments.
So in terms of UX benefits, it kind of sounds like a credit card system, right? Like you have a limit and then you can just spend it. And as long as you repay the solver or the credit card company, you can just reinitiate that limit again and again and spend it across chains.
Yeah, I think it is. It is fairly similar to that. There's some implications that sort of a credit card system has with lending that may not necessarily be the case in every implementation of resource locks, but there's certainly some similar dynamics where it's about the solver fronting on the destination chain. The thing that I will say is I think your analogy there is the case whether you use intent bridge that has resource locks or not. So even just a regular intent bridge has the same lending dynamics with solvers, where the solvers are holding inventory for a period of time on your behalf.
So I see a lot of parallels being made to intent bridges, right? Like even in your comparisons or explanation of resource locks, you always kind of use intents as the relative mechanism to explain resource locks, right? So where does that come from? Maybe we can explore that, and that'll be easier for everyone to understand.
How does it build on top of intent bridges?
Intents, yeah. Like the concept of intents, how does resource locks actually build on that concept?
Maybe it's helpful to sort of draw a bit the journey of how I got to building OneBalance and sort of what OneBalance is, and I think it'll sort of loop into all of this, and my personal journey into getting to resource locks. So I was previously a co-founder at Flashbots, where I was also the chief architect for MEV and MEV Boost, and so I focused a lot of my time on MEV. And a lot of the concerns at the time were around MEV and extraction, and we were trying to minimize, the negative impact of MEV. And that framing never really sort of, rang well with me. And the question I had at the back of my mind is, how can we actually start using MEV as a positive thing, where we're enabling new use cases, improving UX, these kinds of things. And when I published the MEV supply chain that you previously mentioned, there was one part in there that mentioned intents at the start. I think this was before anyone really was building anything with intents. I started thinking more about this, and this led me to think MEV has a clear role in enabling intents, and intents have a clear role in helping fix the UX of cross-chain. And so we did more research with this after I left Flashbots and during our time with Frontier Research, and we came to the conclusion that there was an opportunity here to help optimize the way that intents are being used in a cross-chain world with resource locks in a way that eliminates double spend and reorg risk. And so what we built is OneBalance, which is a company fully founded on the premise that resource locks are a crucial part of the future of Interop and cross-chain. And we have sort of two key products here. We have the OneBalance Toolkit, which is for apps and wallets to help them do chain abstraction. So completely remove gas, bridging, and even the concept of chains from the user experience of their users, so they can just offer any swapping to any chain or any yield opportunity anywhere. And our second product is Resource Lock as a Service, which is helping other infrastructure providers or interop providers integrate resource locks within their architectures and benefits from the speed and cost benefits. So folks like Li-Fi can integrate our resource lock system to be able to speed up the bridging.
And then you tackle resource locks at the account level, right? So what was the thinking there? Because you can technically build this in many different ways. Like you can also have a resource lock intent-based bridge, but then you're technically creating an infrastructure at the account level that other people can integrate. So what was the thinking behind that?
It's been super interesting actually to see how the experimentation around resource locks has evolved, and certainly our thinking around it has evolved as well since we sort of originally introduced the concept. I think there's sort of two main families of resource locks. There's account-based locks and escrow-based locks. So on an account-based lock, you would do the locking on all the assets that are sitting within an account, and that can be done on smart contract accounts, or it can also be done on PEs and MPC. And I think that this is actually like an area that people are should pay more attention to. That there's a lot of capabilities that are unlocked by running permissioning policies within TEs and MPCs, and we're seeing a lot of demand from our customers and our partners for these kinds of solutions. Now, there's the second family, which is the vault-based locking system, which requires a deposit step by the users whenever they want to create the resource locks. And the benefits of the escrow-based ones is that it's more backwards compatible with EOAs, though it comes with different trade-offs in terms of UX. So from our position, we're sort of happy to support any of these approaches with our last product. Our toolkit product is focused again on the wallets and the apps, and so that's mostly focused on the account-based resource locks. Though our vision of the future is there's going to be many flavors of resource locks, and we're happy to help propagate all of them.
Makes sense. Ankit, anything to add to that, like the intense relativity or like your approach towards account-based resource locks?
Yeah, I have thoughts on both of them. So firstly, on the intense thing, I see a lot of the work that we have done with resource locks as just the mirror image of what Stephane did with MEV Boost. And I'll justify that. So like day one, when blockchains were launched, you only had wallets and then you had a node. Like you just blasted your transactions directly to a node. Day two, when people thought, oh, you can do MEV, there was a solver that got inserted in between. And whenever you blasted directly to a node, people would just snipe your fees. And so then the flow was user, solver, and then the node itself. People saw, and I think Phil wrote a paper on this, and then people saw that this was a problem. Like solver is taking a lot of value away from the supply chain, and so these guys developed the MEV Boost, and Stephane was an architect for that. And so now the flow was more like user, solver, MEV Boost system, and then the node. And so MEV Boost system acted as a way in which users and solvers can basically directly communicate with the node and gain some extra properties. And we see whatever we are doing on the resource lock side as inserting someone in between the user and the solver as a mirror image of what the MEV Boost phase was, and just improving the properties that a user or app can get through the transaction supply chain. This is more related to how to improve the UX, how to reduce the cost, how to improve the speed of how you can do cross-chain transactions. That was more related to how you basically reduce the leakage. And so that is how I see what we are doing as an extension to what Stephane has been doing till now. So that's on the intent side. And on the account side, yeah, I think one reason of going down the account route was also that all your assets eventually just rest in your account. And so if the assets are in there, then it is much more easy to basically activate the resource lock on the account level.
So on the UX benefits, right? Like resource locks are faster, but even with intents, like we see bridging times are down to 5, 6, 10 seconds, 30 seconds on average, right? So how much faster can we really get? Like what's the sort of delta there? And what are your experiences with products that are live today? What sort of experiences being unlocked?
So yeah, I think, so there are two things. One is speed, but there's also a cost component to it. So imagine you are doing a cross-chain swap. And if you're doing a cross-chain swap in a setting where there are no resource locks, you send transaction number 1 on the source chain. Now everyone knows that you want to basically swap USDC for some meme coin on Solana or on Base. And then they just front run you on the, so the solver is incentivized to wait for doing the swap on the target chain, but anyone who knows that an order is coming in is not incentivized to wait. And so they just front run you and the user gets a worse price. Now, because you are just directly propagating your signed message to the solver directly without writing it on the public ledger, there's no front running happening anymore. The solver is just fronting you the money right now and eventually getting paid on the target side. So it also reduces all the public information that you leak when you do a cross-chain swap. So it not only has the speed component, but it also has the cost component, and it also improves reliability a lot because you're just instantly getting swapped.
I think this is worth repeating, and I think this is a concept that people don't understand yet. Resource locks are not just about speed. They are about price optimality and execution reliability. And those two things cannot be achieved without resource locks. Because every time you submit an order, you expose MEV, and you need a system that's able to manage that MEV.
Makes sense. Like any conversation that I've seen till now about resource locks, it's always about speed, right? Like, okay, you can do things faster, but then nobody actually goes into the cost benefits or like you're not leaking any sort of information. And the other parallel to Intense is that everything is being done by third-party agents or solvers, right? So there's that reliance on the solver ecosystem. Like, how do you guys see that ecosystem shape up? Because like resource locks are very much dependent on having more and more solvers come up, at least for each application and for their use case.
So I think I'm excited to see the amount of dynamism that there is around the current state of solver networks and more and more of them emerging. You know, part of the part of the meme, I guess, of chain abstraction and interop is we're just creating fragmentation at every level, and then we have fragmentation in solver networks and and solvers and whatever else. But I don't really see it that way. I see a super healthy ecosystem, honestly, in the interop world around the development of ideas and the speed at which they're being developed, because there's this competitive environment and people are really pushing to solve the problem very quickly. And there's still a lot also of participation in standards making processes. So there's clearly a need for two different types of standards here. And the Interop working group is actively working on them, which is an intent standard that defines the semantics of how do you request a call data execution, and then a settlement standard that defines the semantics of which system are you trusting for providing a settlement. The thing that's important with all these is you want both of these systems to also be resource lock compatible. But resource locks sit outside of both of these standards. It's just a new input that goes into these standards. And so, yeah, there's some fragmentation, but there's also standards emerging at exactly the right places. And so the fragmentation is not going to lead to like reduced UX. The fragmentation is leading to more competition, which is actually leading to faster solutions being rolled out for everyone.
Ankit, any thoughts? I know like we've chatted a lot about solver centralization and like how many solvers are actually active in the ecosystem.
Yeah, like the more solvers, the better, till a point. And I think like what you said, that there will be more apps and there will be more fragmentation. But yeah, there are standardizations that are happening, and at the end of the day, standardization is just like solvers don't need to learn a new language for any new application, and then they'll just be able to plug in their systems to every application that follows those standards.
So on the OneBalance account level, are you guys running your own solver right now, or do you use the existing solvers?
So we've taken a very modular approach to our system. Our goal wasn't to come in and say, here's our integrated solution that works in isolation. So we work on top of existing solvers and solver networks, and we just pass over the order flow from our toolkit or the resource locks from our resource lock as a service for them to execute. So we're happy to build on top of the existing Interop frameworks.
Makes sense. And how do you guys think about ERC-7683? Because that's all about like standardizing stuff for solvers, right? So like you said, RLs can be compatible with that standard. So do you see 7683 and the fact that it can get more solvers into the ecosystem as an important factor for adoption for RLs?
Listen, I'm not sure the impact of 7683 is to bring more solvers. I think solvers come where there's order flow. And the only thing that we can do to bring more solvers is to bring more order flow. 7683 is important for the interoperability of solver networks. And so to say that you can route to one solver network or another as an application without having to change or do some custom implementation, I think that's where the intent standard is the most important, rather than on the solver side. So it's more on the application side to be able to route to different solver networks for execution. And yeah, as I mentioned, it's one of the two standards that are relevant. So that's the intent standard. And the second one is the settlement standard. And this is about where are you actually allowing solvers to go execute for settlement and fulfillment of their intents, including sort of which Oracle system or bridge system do you trust to bring back the execution proof from the destination chain. And so, yeah, both those standards are important for interoperability and modularity reasons, so that we don't end up with sort of a monolithic architecture. And people are working hard on them, which I think is great.
I'm also curious to get your thoughts on single slot finality, because I feel like a lot of work with intents and resource locks is done to solvers eat that finality risk, right? So in a world where we have single slot finality, where do we go with intents and resource locks? Do we really need these concepts?
Thank you. Right?
Yeah, but I don't think we live in that world. and every chain has its own properties, which is why people want to deploy assets in them or generate order flow on those chains. And so, as far as there is this rich ecosystem of different type of chains having different type of properties, you will need some solution like this, where you need something like resource locks. And so, if everyone was using Cosmos, for sure you won't need resource locks. But everyone does not use Cosmos. People store money in Bitcoin. People trade memes on Solana. People do DeFi on Ethereum. And if you want to support this rich ecosystem, you would need something like this. There's another thing that we have not touched upon with resource locks, which is that resource locks also let the application basically separate their dependency on a transactional level, on an engineering level, to the source chain itself. And so the only thing that they need from the user is a signature. And as soon as they have the signature, they can give the user the prompt that, okay, you get the execution that you deserve. You want to buy a meme on Solana, just give us a signature and you'll get that execution on that target chain. And so instead of waiting for inclusion on the source chain, the application can just instantaneously give the user a prompt as soon as the user signs it. And that unlocks a couple of things. That unlocks that UX is much more faster. That also unlocks all the pricing benefits that we talked about, but that also unlocks the capability that now you don't have 5 different USDCs. You only have one single USDC. It might be spread across 5 different chains, but from the UX perspective, you just need to sign once, and all those 5 USDCs can be pulled out underneath.
Yeah, I think this is a great question, right? Like, single finality doesn't solve everything. Yes, it helps with reducing the reorg risk and improves the efficiency because of that, but it doesn't solve the MEV problem, right? Like, the transactions are still public, and you don't solve also the problem that you have different trust zones that you're operating between. And so resource locks are always helpful for both those problems. Like, when you're operating across different trust zones, you get sort of a homogeneous execution when you're using resource locks, which is just much easier for applications to think about, rather than having to think about the specific execution semantics of each trust zone that's implemented.
Makes sense. I mean, like you said, there are resource locks are solving a problem at multiple levels, right? So maybe single slot finality can help with the UX, but not the MEV problem, or not the cost benefits, not the pricing benefits. And like right now, it sounds like resource locks are this magic bullet for everything UX, right? But there are always trust assumptions. There are like trusted roles in any sort of like system. What is that for resource locks? Like, what are people trusting so that this system works flawlessly?
Yeah, there's definitely like liveness trade-off, right? And so, but this is the case with every blockchain. The liveness of Ethereum is not the same as the liveness of an L2, and it's a trade-off that is easy to make because it's kind of hidden, but it is there. But with resource locks, you're introducing some additional factors on liveness. I think it's important to note that they are equivalent liveness guarantees as a stage 2 rollup. So when you think about like the security model of resource locks, think of equivalent to a stage 2 rollup. And so resource locks have less trust assumption than a stage 0 or stage 1 rollup. So your base, your optimism, etc. Because they're fully non-custodial, and you have like permissionless rage quit guarantees, but you still have some liveness guarantees or trust assumptions for the period of time of your exit window. And so I think that there's a slight trade-off there where you're adding a time lock on the assets that are locked, but for the benefits of sort of instantaneously being able to transact everywhere at the best price with the most reliability, it sort of seems like a no-brainer trade-off to make for all the users.
So is it fair to say that the trust assumption is similar to trusting an L2 sequencer?
It's similar to trusting a stage 2 L2 sequencer.
Okay. Very important detail there.
Yes.
Yeah. Like no risk of loss of funds, but risk of censorship. That's how I would.
Got it. And then, like, if we have more and more resource lock providers, then there's this sort of like fragmentation across resource lock providers, right? Because I'm basically giving permission to multiple providers to use my funds across chains. So do you see like a world where people just trust one RL provider rather than having permissions with everyone, or like just everyone gets permission for everything?
I do think like different providers will offer different things. I think the switching costs between providers is quite low, and so whether it's users or apps on behalf of users will sort of pick what properties that they care about, and I think they will pick whichever provider is able to offer those properties. I think it's probably similar to how people pick RPC providers today.
Got it. I mean, is it similar to like choosing a wallet in a way? Like, which wallet do I use?
I mean, I don't think so. I think it's like a feature that wallets can offer, but resource locks in themselves are very different than being the key managers for the root assets. When you pick a wallet, the wallet's job really is to secure your keys, and that's the most important thing. They're sort of the root of trust on all the assets that you hold there. Plus, providing all the UX on top of it. Resource locks, I think, offer a much smaller role than that.
Okay, and then so in the current state of the ecosystem, we have all of these L2s building like interop zones, right? Like Superchain with Optimism, Arbitrum has their own zone, and within this zone, there's a lot of UX benefits. Basically, what resource locks or intents kind of optimized to provide. So, how do you see OneBalance fitting in this world? Like, does that kind of downplay the need for something like resource locks, or does it not change anything?
I think the answer is same as for the single slot finality. And so I think the answer is the same. Whatever was the answer for single slot finality.
Maybe there's some nuance, which is you have in cluster versus out of cluster interop, and you can define a cluster as sort of a trust zone. So like if you're operating within a single trust zone, then it's fairly equivalent to just sending a transaction just on Ethereum. And like you don't need a resource lock for a transaction that's only on Ethereum, right? But as soon as you're operating across trust zones, then you benefit from resource locks.
Got it. Makes sense. And then like what would you say is the current state of adoption? Like how many teams are building? How much adoption is there at like an application level? How many apps are using resource locks today?
It's still emerging. What we're seeing is a lot great feedback from the teams that are building on top of our toolkit. They find that it simplifies a lot the development sort of UX that they have shipping their app. It handles all the sort of difficult problems that they would normally have to deal with when they're trying to execute on multiple different chains, and it prevents them the need from essentially hiring an entire team to handle this stuff. So at least what we're seeing is really great feedback from the folks implementing our toolkit, and we're also seeing more and more Interop infra providers come to us asking for help introducing resource locks into their systems. And so, I think the traction is happening at many levels. And although we haven't seen yet any sort of breakout application that sort of is the gold standard for chain abstraction or for resource locks, I sort of have no doubt that that's coming, and we will start to see them over the course of the next year, because all the infra is there, all the tech is ready, and it's really now a question of people doing what people do.
Wait, so in terms of like RL acceleration in a way, what do you think are some of the next unlocks for that to happen? Like, is it better standardization or just a breakout application? Like, I feel like a breakout application is literally every category's golden duck, right? Like everyone is waiting for that app to break out, and then suddenly everyone realizes how cool this is.
I think it's going to happen. It's the reason why it's just a strictly better design. And when you have strict dominance, it turns from being a bet to being an inevitability, and so it's just a matter of time until we get that. And yeah, at least my bet is that it happens within the next year.
And what would you say is like the use case that would actually be best suited for resource locks?
People are still experimenting. We'll see what that is. That'll be like trying to determine what the breakout application is, and it's impossible to know. People are experimenting. People are going to see, and it will take some time before we see that thing emerge. So I honestly have no idea. I'm just excited that people care about the concept and are taking the jump into it, because I think fundamentally this will help solve a lot of the issues that Ethereum has brought upon itself with the fragmentation, and unlock the most that blockchains have to offer for the wave of consumer demand that we are seeing now.
Ankit,
I,
what
yeah,
do you think? What are you excited about?
I do think that people are underestimating the TE-based accounts and what they
Mhm.
have to offer uh, in terms of just UX. And like last year, we were just comparing the growth of smart contract based accounts and TE based accounts like Privy or Turnkey. And if you just chart the growth of those two, you'd see like a huge difference. And primarily, like the thing that we figured out was every application wants to give users Google based SSO, and you cannot give Google based SSO into smart contract accounts. And so every application, basically, even if they were a decentralization maxi and they wanted to do everything on chain, they were not able to give this feature set to their users, and so user requests basically force their hand into adapting TE based accounts. And so we have seen, and we also predict the speed of TE based accounts uh, getting faster compared to smart contract based accounts. And so our toolkit is basically optimized for giving chain abstraction and resource lock capabilities for these type of accounts. And so if you are an application building on Privy or Turnkey and you want to basically give snappy UX to your customers, then please reach out.
I mean, talking to you guys, I get the feeling that you're like very heads down building long term sort of builders, right? Like trust the process and it will happen. So where does that sort of come from? That sort of thinking.
Where does that come from? I don't know. I guess it's we spent so much time debating potential futures that at some point you land on one that you have really high conviction. And you realize that you have this unique insight that the rest of the industry doesn't have yet. And then that's where, the sort of magic starts to happen, because at least what I've learned building startups is there's like the lean startup playbook, which is you just build an idea and you like take a blind bet that's going to work, and you iterate from there if you don't get market validation. But the startups that work the best are the ones that are able to have some thesis about the future and know that if they are successful at building it, that there will be demand. So they're not betting on there being demand; they're betting on their ability to deliver it, and that requires like a very strong, unique insights and sort of first principles thinking that sets a thesis apart from others.
I would also just say that this is also how Stephane operates. And so very initially when I started working with him, I just a researcher coming, like I used to tell Stephane, oh, this is such a cool idea, let's do this. And Stephane would be like, but why would this and this party not just do it themselves? And so it basically forces you to think about all the different angles of actually should you even start developing engineering, devoting engineering resources into building something before even building it, and it just saves a lot of time. And so when a particular idea crystallizes and follows through all those checklists, then it is worth basically putting some time behind it.
Makes sense. I love the chemistry between you guys because it seems like you're on the same page here. And honestly, like I learn a lot from your work, like both of your work. So I hope that this vision actually crystallizes someday, and I hope I can like also play a small part somewhere.
I think you're doing a huge part, and to give a shout out to the work that you've done. I think you've evangelized extremely well around Interop and educated a ton of people about how this system works. So I think it wouldn't be possible for the industry to get to where it needs to be without the work that you're doing.
I really appreciate that, but one thing that I'm not good at is probably taking compliments. So I think this is this is the perfect point to like end this conversation.
You're doing a great job, Arjun. You're doing a great job.
No, thank you.
The best job.
I think we can stop. But thanks a lot for taking the time. I feel like resource logs are still very new. Not a lot of people understand the concept, and there's so many points that nobody talks about, right? Because they're coming from you guys. So I hope within this conversation there are some of those points, and then later on someone can build on top of those things. And yeah, thanks a lot for your time.
Thank you.
Thank you.